In 1785, the French astronomer Charles Messier noted a faint curious object in the constellation Corvus. Through the telescopes of his age, it was little more than a dim patch of light, strange but quiet, easy to mistake for something settled and complete. Today we know that object as the antennae Galaxies, a pair of great star systems caught in the long act of tearing at one another. What once looked like a smudge now appears as two luminous bodies trailing vast arcs of stars and gas, as if the sky itself had been pulled into ribbons. And yet even that image can mislead us, because what we are seeing is not a crash in any ordinary sense. It is something slower, subtler, and in many ways more unsettling than collision. When we hear that galaxies collide, we imagine impact. We imagine stars striking, stars, worlds, shattering fire, spreading instantly through the dark. But the universe rarely follows the habits of human language. Galaxies are so spacious and stars so widely separated that even when two enormous systems pass through one another, most of their suns never come close to meeting at all. What collides is not usually star against star, but order against gravity, motion against motion, shape against time. A galaxy can begin to lose itself long before anything we would call contact has truly occurred. That is part of what makes these encounters so strange. They unfold over spans so vast that no human being, no civilization, no species could ever stand still long enough to watch one from beginning to end. A spiral arm bends. A tail of light is drawn out into the black. Gas drifts inward. New stars are born in the middle of upheaval. Somewhere deep inside the bright confusion, old paths are broken and new ones begin. By the time the process is over, two recognizable galaxies may have become a single object that no longer resembles either one that came before. So, tonight we are not entering a story about sudden destruction. We are entering a story about slow unmaking, about how gravity can take something as immense and graceful as a galaxy, and over ages beyond imagination, loosen its form, disturb its memory, and turn it into something else. What does a galaxy become when it can no longer remain itself? And what does it mean that in the universe, even ruin can be a way of making? At first glance, the phrase seems simple enough. Two galaxies collide. The mind reaches for the nearest familiar image. Two bodies rush together. Matter slams into matter. Light bursts out at the instant of impact. We borrow the language from weather, from war, from traffic, from every earthly event in which motion ends in contact. Even the word itself presses us towards speed and force. It tells us to expect a moment, but a galaxy does not live by moments in the way we do. A galaxy is not a solid thing traveling cleanly through emptiness. It is a vast arrangement of stars, gas dust, dark matter motion, memory, and time. It is less like a stone and more like a living pattern, one held together not by touch, but by gravity. When two of these patterns meet, the result is not usually a blow. It is a long disturbance, a change in paths, a rearrangement so slow that what appears violent to the intellect can look almost graceful to the eye. That is the first truth we have to accept if we want to understand what really happens when galaxies collide. Most of the stars inside them do not strike each other at all. They pass by often at vast distances, carrying on through a field that is far emptier than instinct allows us to imagine. A galaxy may contain hundreds of billions of stars, and yet the space between those stars is so immense that direct stellar collisions are extraordinarily rare. When astronomers say that galaxies collide, They do not mean that countless suns are smashing together like sparks from a hammer blow. They mean that two colossal gravitational systems have begun to pass through one another's influence, and once that happens, almost nothing inside either galaxy can remain arranged in quite the same way. This is difficult to feel at first, because the eye is easily deceived by brightness. When we look at images of galaxies, especially the great spirals, they appear full. Their arms seem dense with light. Their central bulges glow with such concentration that we almost imagine texture, something woven, something packed. But this is the visual language of distance. Light smooths over emptiness. From far away, billions of separate stars blur into a luminous whole. The galaxy seems like an object with a surface, something you could almost touch if you came close enough. It takes effort to remember that the shining shape is really an arrangement spread across tens or hundreds of thousands of light years, a delicate architecture suspended inside unimaginable space. If one could move inward and inhabit that scale, the illusion would fall away. The stars would no longer seem crowded. They would seem lonely. Each one would travel through an expanse so wide that the very idea of collision would begin to lose its ordinary meaning. The encounter between galaxies would still matter profoundly, but it would matter for a different reason. Not because stars are striking one another, but because gravity is altering the routes they follow. What changes is not usually the stars themselves. What changes is the choreography. And choreography is not a small thing. It is identity. A spiral galaxy is recognizable because countless stars, gas clouds, and dust lanes participate in a broad, shared order. Its arms are not rigid structures, but patterns of motion and density. Its shape is an agreement sustained across time. When another galaxy approaches, that agreement begins to weaken. Gravity tugs unequally on different regions. Outer stars are drawn one way, inner gas another. Orbits that held their form for ages are stretched, tilted, and disturbed. Tidal forces begin their work, and what follows is less like a crash than like music being pulled out of tune. This is why the first images of interacting galaxies feel so unsettling. They are beautiful, but their beauty is troubled. There are tails that should not be there, long. Luminous streams stretching out into darkness, as if the galaxies have begun to come apart at the edges. There are bridges of material linking one system to another, as though space itself has become viscous. There are warped disks, doubled nuclei, bent arms in regions where young blue stars flare in places the older, calmer galaxy would never have arranged on its own. The shapes are spectacular, but what makes them truly moving is that they still carry traces of what they used to be. They are recognizable and wounded at the same time. That sense of wounded recognition is important because it brings us closer to the real drama. A galaxy collision is not interesting because it is louder than ordinary cosmic life. It is interesting because it exposes how provisional a galaxy's form has always been. From a human distance, a spiral galaxy looks serene, as if its arms have always been there and might remain forever. But the moment another great mass comes near, that calm begins to reveal itself as temporary. The spiral was never a permanent object. It was a temporary balance. The collision does not create fragility from nowhere. It reveals the fragility that was already there, and yet this revelation does not happen quickly. That is the second truth. Even when two galaxies are already in the act of interacting, the process unfolds across spans of time, so large that the mind almost refuses to inhabit them. The first close pass may begin the transformation, but the consequences continue for hundreds of millions or even billions of years. One galaxy may swing past another, drawing out tails and disturbing gas, only to drift apart again before gravity slowly brings them back for a deeper encounter. The final merging of their central regions may happen long after the first visible signs of damage have appeared. What we call a collision is often an extended sequence of meetings, departures, returns, and rearrangements. It is not an instant of impact. It is a drawn-out surrender of old form. That slowness changes the emotional character of the event. If galaxies truly smashed together, in the common sense, the story would be simpler. It would belong to the same family as every other dramatic ending. But because the process is gradual, the feeling becomes stranger. A galaxy does not vanish in a flash. It lingers in partial selfhood. It can still look like a spiral, even as its arms begin to unwind. It can continue glowing with old stars, while new ones ignite in distorted clouds. It can appear intact from one angle and deeply changed from another. The collision becomes a long interval in which a galaxy is still itself and no longer fully itself at the same time. For human beings, that may be the most haunting part. We are creatures who look for thresholds. We want to know when one thing ends and another begins. We want to place our finger on the border between before and after. But galaxies do not grant us that clean division. Their collisions belong to a universe in which identity can be lost by degrees. There is no single moment at which a spiral quietly declares that it has ceased to be one. There is only the steady accumulation of changes. A tail drawn farther out, a stream of gas forced inward, an orbit broken, a center brightened, a shape no longer recoverable. The ending is not absent, but it is distributed. Even the apparent stillness of the night sky contributes to the misunderstanding. To us, the stars seem fixed. Constellations appear unchanged across lifetimes. Galaxies, when seen through a telescope, feel stiller still. They are faint and remote, like ornaments hung far beyond the scale of living time. Because we do not watch them move, we unconsciously assign them permanence. Yet the stillness is only a function of our brevity. The universe is in motion everywhere. Galaxies orbit in clusters, drift through filaments, approach, recede, accrete, and interact. The great forms that seem so calm are not frozen paintings. They are currents. Once that becomes clear, the phrase "galaxies collide" begins to sound less like a sentence about contact and more like a sentence about influence. To collide in this context is to enter another system's power. It is to have one's paths altered by the presence of another enormous history. That history may be written in stars, but it is also written in dark matter, halos extending far beyond the visible galaxy, in reservoirs of gas waiting to be compressed, in old orbital patterns ready to be disturbed. The visible encounter begins long before the galaxies seem to touch, because gravity does not wait for surfaces. It begins its work across distance, and gas, unlike stars, answers that work in especially dramatic ways. Stars largely keep to themselves, continuing along altered orbits through the deep emptiness. Gas clouds are more vulnerable. They can be compressed, shocked, heated, and driven inward. Regions that were quiet become unstable. New stars may begin to form. What the eye reads as destruction can therefore coincide with a sudden flowering. This is one reason the most famous interacting galaxies are often full of brilliant blue clusters and bright knots of star formation. The collision does not simply tear structures apart. It changes the conditions under which new light can appear. So, the event contains a paradox from the start. It is less literal than we imagine, but more transformative. Less about bodies, striking more about systems, losing equilibrium. Less about immediate ruin, more about slow alteration. When we first hear that galaxies collide, the error is not only that we picture too much violence, it is also that we picture too little transformation. We imagine a blow when we should imagine a long negotiation between gravity and form, between motion and memory, between the shape a galaxy has been and the shape it may no longer be able to keep. Perhaps this is why interacting galaxies have such a peculiar emotional pull even for those who know little astronomy. They seem to show something familiar and impossible at once. We recognize the elegance of the spiral, the symmetry of the disk, the comfort of repeated structure. Then we see that structure pulled outward into arcs and plumes, and some quiet part of the mind understands that order has been interrupted. But the interruption is not chaotic in a random sense. It is patterned. The damage has form, the aftermath has rhythm. What we are seeing is not the cancellation of beauty, but beauty passing through a more troubled state. And this is where the documentary must begin to slow its own gaze. Because if we remain only at the level of astonishment, we will miss the deeper story. The images alone can seduce us into thinking that the meaning of a galaxy collision lies in spectacle. In truth, the spectacle is only the visible skin of a longer reality. Every tail bridge and distorted arm is an answer to a question asked by gravity. Every bright region of newborn stars is evidence that matter has been compressed and redirected. Every warped silhouette is a record of forces acting across immense scales. To look at an interacting galaxy properly is to understand that one is not merely seeing an object. One is seeing time made visible. That may be the most difficult adjustment of all. Human beings are used to reading time through decay, through wrinkles, ruins, weathering ash. But galaxies display time differently. Their histories are often written in structure. An ordinary spiral suggests long sustained order. A peculiar galaxy suggests disturbance. A merger remnant suggests that disturbance has already passed through culmination and left behind a new stability. The sky in this sense is full of forms that are also clocks. To understand collisions, astronomers had to learn how to read those clocks, to see that oddness was not an accident of appearance, but a stage in a much longer process. That recognition did not come all at once, it had to be learned. Strange galaxies had to stop being mere curiosities and start becoming evidence. Their tales had to be read as consequences, their distortions as history, their asymmetries as clues rather than flaws. In other words, before astronomers could truly explain what galaxy collisions do, they had to learn how to see them at all. And that is where the story must go next. Not yet deeper into the collision itself, but into the minds that first realized that these troubled shapes in the sky were not mistakes of nature. They were nature revealing in slow motion how one galaxy can begin to lose itself in the presence of another. To understand galaxy collisions, astronomers first had to learn a quieter skill. They had to learn how to look at an unusual shape and resist the urge to dismiss it. A bent arm, a long tail, a bridge of light between two galaxies, a pair of glowing cores pressed too close together. These things did not initially arrive in human knowledge as a clear story. They arrived as oddities. They sat in the sky like unresolved thoughts, difficult to classify, beautiful, in a way that was somehow also inconvenient. For a long time, astronomy could describe them before it could truly explain them. That hesitation is not surprising. Once astronomers had accepted that the spiral nebulae were not nearby clouds, but distant galaxies, the great task of the early 20th century became one of order. Galaxies had to be sorted, compared, arranged into families. Smooth ellipticals, elegant spirals, barred spirals, lenticular systems. Each type seemed to promise that the universe, when properly viewed, possessed a kind of underlying grammar. Classification brought relief. It meant the sky could be read. It meant the countless islands of light were not chaos, but members of a legible cosmos. Yet classification has its own blind spots. The moment a system of order is established, whatever does not fit cleanly inside it begins to seem secondary. Peculiar galaxies existed in plain sight, but peculiarity itself did not always feel like a path to deeper truth. Sometimes it looked like noise. Sometimes it looked like damage with no interpretive value. Sometimes it looked like an isolated exception, a curiosity for the edge of the catalog rather than the heart of theory. The strange systems were seen photographed, named, and noted, but their oddness was not yet granted full explanatory weight. There is a recurring pattern in the history of science, and it appears here as well. Before a new understanding takes hold, the evidence often exists in a partially muted form. The data are present, but the imagination needed to organize them has not fully arrived. The sky offers a form, but the mind has not yet decided whether that form is accidental, decorative, or meaningful. This is why the path toward understanding galaxy collisions was never only a matter of better telescopes. It was also a matter of learning that irregularity can be a record, that distortion can be history, that an object that looks broken may in fact be telling the truth more openly than one that looks calm. One of the earliest and most quietly beautiful steps in that direction came from an astronomer working in a way that now feels almost impossible to imagine. In the 1940s, Erich Holmberg studied galaxy encounters not with a digital simulation, but with arrays of light bulbs. He understood that gravity and light both obey inverse square laws, and he used brightness as an analog for gravitational interaction. It was a modest-looking experiment, almost fragile by modern standards, yet conceptually it was profound. It suggested that encounters between galaxies could produce large distortions, transfer energy, and alter motion in lasting ways. The result was not yet a cinematic model of colliding galaxies as we know them now, but it was a crucial gesture of thought. It treated galaxies not as isolated decorations in the sky, but as systems capable of changing one another. That shift in attitude mattered. Once galaxies were imagined as interacting rather than merely existing, peculiar shapes began to acquire a new dignity. They no longer had to be dismissed as anomalies. They could be clues. Their unusual forms might not be departures from nature's order, but evidence of another order still in motion, one that only revealed itself fully when systems met, pulled warped, and passed through one another's influence. Still, the change was slow. Observational astronomy in the mid-20th century was rich in images, but images alone do not always persuade. A strange shape can inspire wonder without yielding a mechanism. It can be admired without being understood. What was needed was a way to connect visible oddness to physical process, to say not only that a galaxy looked disturbed, but that its disturbance followed from specific gravitational events. Before that connection grew firm, astronomy had to spend time in a more uncertain zone, one in which the sky was full of suggestive forms and not yet full of settled explanations. This is part of what made the work of Fritz Zwicky and others so important. Zwicky photographed galaxies with extended features, disrupted structures, and material drawn out beyond the neat limits that classification seemed to prefer. I was interested in the dynamical life of galaxies, in clusters in motion, in systems acting upon one another. Some of his claims were far ahead of his time, and not all of his ideas landed smoothly in the scientific culture around him. But he helped normalize a crucial intuition that what lies outside a galaxy's tidy silhouette may be as revealing as what lies within it. A tale was not merely an aesthetic flourish. It might be a consequence. A bridge was not merely odd. It might be a trace of interaction. Then came one of the most visually memorable documents in 20th century astronomy, Halton Arp's Atlas of Peculiar Galaxies, published in 1966. The title itself is revealing. Peculiar, not yet mergers, not yet a seamless chapter in galaxy evolution, but peculiar. ARP gathered strange systems together, and in doing so, gave their strangeness coherence. Here were galaxies with arms flung wide, galaxies paired in asymmetrical embraces, galaxies with jets, rings, loops, knots, and luminous distortions that resisted ordinary categories. The atlas did not solve the problem by itself. It did something subtler and perhaps just as important. It forced the astronomical imagination to dwell with irregularity long enough for irregularity to become central. There is something almost literary in that achievement. Once scattered oddities are placed together, they begin to form a language. Repetition emerges. Motifs appear. One starts to notice that the same kinds of distortions recur in different systems, as if the sky were writing variations on a theme. A tail here, a bridge there, a double nucleus elsewhere. The individual images remain strange, but the strangeness begins to look patterned. And the moment pattern appears, explanation draws near. Yet explanation did not arrive by observation alone. It needed motion. It needed the ability to imagine not just how a galaxy looked, but how it became that way. This is where Alar Toumre and Juri Toumre changed the conversation. In the early 1970s, they used numerical simulations to show that many of the remarkable forms seen in interacting galaxies could arise naturally from gravitational encounters. The long tidal tails, the bridges, the stretched and bent structures that had seemed so visually extravagant now had a dynamical logic. They were not arbitrary. They were the expected consequence of massive systems disturbing one another across time. The importance of this moment is difficult to overstate. The Toumrists did not simply add a new result to astronomy. They gave the peculiar sky a grammar of becoming. They showed that galaxies could no longer be treated as static specimens alone. They were actors in a slow, physical drama. Their distortions were not random blemishes on otherwise pure forms. They were the forms of process itself. Once that became clear, the emotional atmosphere of galaxy observation changed. A distorted galaxy was no longer merely something odd to behold. It became a frozen interval in a larger event. To look at such a system was to look at a moment inside a transformation too large for any human lifetime to witness directly. Astronomy could not sit and watch a merger unfold from beginning to end, but it could gather many galaxies at many apparent stages and begin reading them as parts of one long sequence. The sky became an archive of slow-motion events. That idea has a special beauty because it turns limitation into method. Human beings are too brief to watch galaxies change in real time. Yet the universe provides many examples at once. One system may show an early disturbance. Another may show long tidal tails. Another may show overlapping disks and intensifying star formation. Another may show a late-stage remnant with a single core and lingering loops of debris. Each galaxy is its own history, but together they allow the mind to reconstruct a process no one could ever observe in full. Science in this case advances by assembling a story from scattered stillness. Even so, there remained a difference between theoretical plausibility and deep observational richness. Simulations could explain why distortions might arise, but astronomy still needed sharper views of the aftermath, especially the parts that revealed not only gravitational disturbance, but the birth of something new inside it. This is where later space-based observations, especially from Hubble, transformed the field again. They made merger remnants and interacting systems visible in ways that were no longer merely suggestive. One could see young star clusters blazing in tangled regions. One could resolve structure inside the wreckage. One could observe not just damage, but creation. The antennae galaxies became one of the most powerful examples of this new clarity. What earlier observers had seen as a faint, peculiar patch became through Hubble a dramatic record of interaction, filled with bright blue regions of recent star formation. The tails were there, the disrupted bodies were there, but so too were the dense young clusters that revealed how gas-rich collisions could trigger new stellar birth on extraordinary scales. The merger was not simply deforming two galaxies. It was altering the conditions of light itself. It was producing a future that neither galaxy left alone would have arranged in quite the same way. This mattered because it widened the meaning of collision. The old question had been whether peculiar forms could be explained by interaction. The new question became larger. If interactions could distort galaxies, trigger starbursts, reshape orbits, and eventually help produce entirely different kinds of remnants, then collisions were not marginal events. They were part of the universe's method. They belong not only to the category of spectacular exceptions, but to the history of galaxy evolution itself. That realization changed how astronomers thought about the calm shapes they had once taken as basic. A spiral galaxy, so graceful from a distance, could now be understood as something that might one day be unmade by encounter. An elliptical galaxy, so smooth and settled, might carry the memory of earlier violence, long since softened into a new stability. A merger remnant was not merely a broken thing. It was evidence that form in the universe is often temporary, and that large-scale order can arise again after upheaval, though not always in the same shape. There is also something quietly philosophical in the way this knowledge emerged. Astronomers did not discover galaxy collisions by watching a single dramatic event explode before them. They discovered them by learning to trust traces. They learned that stretched shapes, asymmetries, clusters of young stars, and double nuclei were not miscellaneous curiosities. They were signatures. The universe, as it turned out, had been leaving evidence everywhere. The problem was not that the evidence was hidden. The problem was that it first had to be recognized as evidence. In that sense, the history of peculiar galaxies is also a story about scientific patience. The sky does not always present its meanings in direct language. Sometimes it offers only forms that seem awkward inside current understanding. It asks the observer to stay with the awkwardness long enough for a new pattern to emerge. Peculiar galaxies were once exactly that sort of challenge. They sat just outside the comfort of neat classification, asking whether the cosmos might be more dynamic, more relational, and more historically textured than it first appeared. By the time that lesson had taken hold, the strange sky no longer looked quite so strange, or rather, it looked strange in a more intelligible way. A tale became a tidal tale. A close pair became an interacting system. A luminous bridge became matter caught in gravitational exchange. A disturbed remnant became the aftermath of a long unmaking. The vocabulary changed because the understanding changed. Astronomy had not simply found a new set of objects. It had found a new way of reading time and shape. And once that way of reading had been learned, a deeper question opened almost immediately. If these peculiar galaxies were not isolated curiosities, but records of encounters, then what did the encounter itself actually begin to feel like from inside the structure of a galaxy? At what point does order first start to loosen? How does one graceful spiral begin to realize in the presence of another that its old symmetry cannot be kept? The answer does not begin at the final merger, nor even at the moment the galaxies seem most dramatically intertwined. It begins earlier at the first close pass, when two great systems swing near one another and the long work of transformation quietly starts. If a galaxy could remember the instant its old certainty began to loosen, it would not remember an impact. It would remember an approach. Long before, two galaxies appear from our distant human vantage to touch or overlap, they have already entered one another's influence. Their visible disks may still seem separate in the dark, each one carrying its own recognizable shape, its own balance of stars and gas, its own long-formed habits of motion. A spiral may still look like a spiral. Its arms may still turn with familiar grace around a bright central bulge. From afar, it can still seem self-contained. But galaxies are larger than the light by which we first know them. Their gravitational reach extends far beyond their visible edges, and so the real beginning of a collision is not marked by contact in any ordinary sense. It begins when one vast system starts to pull upon another, strongly enough that the old paths inside each can no longer remain undisturbed. This is the stage astronomers sometimes reconstruct only in hindsight, because the first pass is both decisive and deceptive. It is decisive because so much of what follows begins here. It is deceptive because the full consequences are not immediately obvious. The galaxies may swing past one another and continue on apparently surviving the encounter. There is no immediate annihilation, no sudden collapse into a single object. For a time, they may even seem to have escaped. And yet the first pass is rarely innocent. It is the moment when equilibrium begins to fail. To understand why it helps to remember what a stable galaxy truly is. A spiral galaxy is not a rigid wheel. Its stars are not fastened into place like stones in carved wood. Everything within it is in motion. Stars orbit through the galactic potential. Gas drifts, compresses, cools, and heats. Dust traces lanes of density and shadow. Even the visible arms are not fixed structures, but broad patterns, temporary waves of higher density, moving through a sea of orbiting material. The shape holds not because it is solid, but because an enormous number of motions accumulated across time remain loosely coordinated. The galaxy is a settled conversation between gravity and movement. The first pass interrupts that conversation. As one galaxy swings near another, gravity does not pull equally on every part. The nearer side feels one strength of tug, the farther side another. Outer regions less tightly bound than inner ones are especially vulnerable. Orbits begin to stretch. Stars are displaced from the paths they would have followed in isolation. Gas responds with even greater sensitivity, its clouds compressed in some places and flung outward in others. The galaxy is not torn apart all at once, but the old agreement that sustained its form begins to fray. The encounter reveals that what once looked like permanence was in truth only a balance maintained under certain conditions. What is moving? When galaxies pass one another is not just matter, but momentum, energy, orientation, and history. Each system arrives carrying the long result of countless earlier orbits. The first pass forces those histories into relation. If the galaxies approach at the right angles and distances, the consequences can be profound. One side may be drawn out into an arc. A spiral arm may unwind or bend. Gas may be driven into denser lanes. Material may begin to stream outward into what from afar will later appear as tails or bridges. None of this resembles the clean violence of collision in the human sense. It resembles instead the first visible sign that a structure has entered a field too strong to remain what it was. There is something eerie about this stage because it often preserves so much of the galaxy's former beauty. The spiral does not vanish on first encounter. It lingers. It still presents the memory of order, even while order is already under strain. This is what gives early interacting systems their peculiar emotional quality. They do not look ruined in the final sense. They look interrupted. They look as if some unseen hand has touched the pattern and caused it to hesitate. ARP 142 offers one of the clearest modern images of this hesitation. In ordinary descriptions, it is often called the penguin and the egg, a name that captures the almost whimsical silhouette the interacting pair presents to our eyes. Yet beneath that playful nickname lies a serious piece of cosmic history. One galaxy in the pair has already begun to show the consequences of a close encounter. Its spiral structure no longer sits in calm symmetry. Dust and gas have been disturbed. Star formation has brightened in places where the interaction has compressed material. What had once been a more settled spiral identity now carries visible evidence that another galaxy has come too near, passed too close, and altered the terms under which it can remain itself. What makes ARP 142 so valuable in the story of the first pass is not merely that it is picturesque, but that it reveals how quickly a recognizable form can begin to loosen. The galaxies have not yet completed their merger. The process still has a long future ahead of it, and yet the evidence of disturbance is already unmistakable. This is often the character of a first pass. The decisive change does not wait for the final union. It begins at the moment of near approach, when gravity reaches inward and outward at once, unfastening the old geometry. NGC 520 offers another kind of lesson. Here the encounter is farther along, but still legible as a passage rather than an ending. The system appears broken, asymmetrical, deeply disturbed. One is no longer looking at two calm disks simply passing nearby. One is looking at the visible consequence of a close interaction whose effects have accumulated over hundreds of millions of years. The old shapes have already yielded enough that the observer can feel how enduring the first disturbance must have been. A single close pass, depending on mass angle and timing, does not simply leave a bruise. It can begin an entirely different future. This is one of the hardest things to internalize. Human experience trains us to think of transformation as proportional to contact. A light touch should do little. A devastating result should require a devastating blow. But galactic interactions teach another logic. Because the systems involved are so immense, and because the timescales are so long, even a near passage can become destiny. The first pass is not always the loudest phase, but it is often the phase in which the old order ceases to be recoverable in any simple way. The galaxies may separate again after their initial approach, but they do not return to innocence. They carry each other's influence away with them. That temporary separation after the first pass is important to dwell on because it gives the entire process its strange rhythm. In many mergers, the galaxies do not meet once and simply remain together. They approach, disturb one another, and then continue outward along altered trajectories. For a time, they may widen their distance again. If one did not understand the larger gravitational story, one might imagine the event has passed. But it has not passed. Orbital energy has been redistributed. Tidal forces have drawn material outward. Dynamical friction, the slow transfer of motion through the gravitational interactions of many stars and dark matter, begins to drain the galaxies of the freedom they once possessed. The first pass is not a finished event. It is the opening sentence of a longer inevitability. That is why this stage carries such tension. It is the moment in which the future is written, but not yet completed. The galaxies have already changed each other, and yet they remain visibly apart. The observer stands in a kind of cosmic interval, able to see the beginning of unmaking without yet seeing its end. There is in that interval a peculiar sadness. A galaxy is still almost itself. Its symmetry is not wholly lost. Its disk may still be traced. Its nucleus may still hold calmly at the center. But the disturbance has begun, and once it has begun, time will work in a new direction. Perhaps that is why the first pass feels more intimate in some ways than the final coalescence. In the later stages, the spectacle becomes more obvious. Tails lengthen, cores approach. The aftermath grows undeniable. But in the first pass, what we witness is vulnerability. A galaxy reveals how much of its calm depended on the absence of another comparable mass nearby. Its beauty turns out not to be a permanent condition, but a temporary agreement with circumstance. And still, this stage is not only about loss. Even here, where order first begins to loosen, the seeds of later creation are already being planted. Gas clouds compressed by the encounter may begin forming new stars. Some regions brighten with youth, even as the larger structure becomes less coherent. This dual movement, outward disruption and inward ignition, is one of the signatures of interacting galaxies. The first pass does not merely deform. It redistributes possibility. Material that once followed quiet paths is now forced into new conditions. Some of those conditions are destructive, some are fertile. The galaxy has begun to leave one life, but it is also preparing another. This is worth lingering over because it changes the emotional meaning of disturbance. To the earliest visible damage can feel like the beginning of decline, and on one level it is. The old form is no longer secure. But the universe does not divide endings and beginnings with the same neatness human language prefers. The first pass is already both. It initiates unraveling and it initiates transformation. It is the point at which the galaxy's identity becomes unstable, not yet because it has disappeared, but because too many new forces have entered the structure for the old one to remain whole. One might say that a first pass is when a galaxy begins to remember that it is made of motion. In isolation, that motion can produce a serene appearance. Under perturbation, the underlying dynamism becomes suddenly visible. Arms bend because they were always trajectories. Tails form because outer stars were never nailed in place. Gas compresses because it was always responsive, always ready to answer pressure with light. The encounter strips away the illusion of fixity and shows the galaxy for what it always was: not an object, but a temporary arrangement of paths. This is also why the first pass matters so much to astronomers trying to reconstruct the history of a system. Later stages can be spectacular, but they are often harder to unravel. By then, the structures have been more deeply transformed, sometimes fused, sometimes obscured by dust, sometimes complicated by intense central activity. The first pass, though still intricate, preserves a more readable form of cause and effect. One can see the beginning of tails, the bending of disks, the asymmetry of response. One can study how the encounter geometry shaped the aftermath. It is an early chapter, but often a revealing one, because the initial signature of gravitational disturbance remains visible before the narrative grows more crowded. And that narrative is always more crowded than a single image can show. Behind every photograph of an interacting pair lies a deeper arrangement of invisible mass. Dark matter, halos overlap, and influence the encounter long before visible structures fully betray what is happening. Behind every warped spiral arm lies an altered orbital history for countless stars. Behind every bright patch of new star formation lies a sequence of compressions, shocks, and instabilities in gas that has been forced out of its previous state. The first pass is simple only in name. In reality, it is the opening of a complex chain of physical responses, each unfolding on its own scale, each contributing to the gradual undoing of the old galaxy. Yet from the human side, perhaps the most moving truth remains the plainest one. A galaxy can begin losing itself before it has merged, before it has shattered, before it has even visibly ceased to be what it once seemed. The process starts with proximity, a near encounter, a pull, a passing too close to remain unchanged. There is something almost tender in that, though that the consequences are immense. The first pass is not an explosion. It is a threshold crossed in silence. By the time the galaxies drift apart again, if only for a while, the sky already holds the first lines of the story to come. Their structures are no longer merely their own. Their future paths are now entangled. Material has begun to stream away from old centers of order. Symmetry has been touched and found to be fragile. The galaxies still exist as distinct presences, but the distinction has become less secure than before. One can already sense, even if only faintly, that their old separateness will not last forever. And as the consequences of that first encounter continue to unfold, the most visible signs of change begin to lengthen and spread. The galaxies do not simply carry hidden disturbance within them. They start to write that disturbance across space itself in arcs, tails, bridges, and luminous debris, as if the process of losing shape must first announce itself by drawing shape outward into the dark. After the first pass, a galaxy does not immediately become unrecognizable. That would be easier to understand. A clean break of visible before and after would satisfy the human appetite for clear endings. But the universe is rarely so abrupt. What follows instead is a long interval in which shape begins to loosen without entirely disappearing, as though the galaxy were trying for a while to continue being what it has always been. Its spiral arms may still be visible. Its center may still glow with familiar steadiness. Its disk may still hold together from a distance. Yet something in the arrangement has been altered so deeply that the old form can no longer remain self-contained. The galaxy starts to write its disturbance outward. This is the stage in which the collision becomes legible across space. The consequences of gravity are no longer confined to altered orbits hidden within the disk. They begin to appear as extensions, asymmetries, arcs, bridges, plumes, and tails. Matter that once belonged to the quiet discipline of a spiral pattern is drawn far beyond the place where it would have remained in isolation. The galaxy begins to trail itself behind. A portion of its history is pulled outward into the dark, where it lingers as luminous evidence that the old equilibrium has been broken. Tidal tails are among the most haunting of these forms. They seem almost too expressive for nature, long sweeping streams of stars and gas extending from galaxies, like gestures that have gone on far longer than intended. To the eye, they can look delicate, even elegant, but their elegance is deceptive. A tidal tail is not decoration. It is matter that has been redistributed by unequal gravitational pulling, often from the more weakly bound outer regions of a galaxy. Stars and gas that once moved within a relatively ordered structure are drawn into elongated paths, flung outward, while still remaining part of the broader history of the encounter. The tail is graceful only because the forces that made it acted over immense time and distance. Its beauty is the beauty of order being stretched thin. What makes these tails so moving is that they are both departure and attachment at once. They extend far from the parent galaxy, yet they do not feel fully detached. One can still sense the original center in them, as though the galaxy were being slowly pulled apart but had not yet finished letting go. This is why interacting systems often feel less like broken objects than like troubled ones. The matter has not exploded away in randomness. It remains connected by motion, by origin, by the memory of where it once belonged. A tale is not simply debris. It is a visible record of relationship. Sometimes the relationship is written not in a tale, but in a bridge. Between two interacting galaxies, there may appear a luminous band or stream, a structure that seems to bind the systems together across the dark interval between them. The effect can feel almost impossible, as if the galaxies had become aware of each other and reached out. Of course, no such intention exists. The bridge is a dynamical consequence shaped by tidal interaction, by material responding to gravitational disturbance, by paths that have been bent out of their former symmetry. And yet the image carries real emotional force because it makes the interaction impossible to deny. The galaxies are no longer merely near one another. Their histories have begun to overlap in visible form. There are systems in which the whole disturbance seems to take on a nearly narrative quality. The mice galaxies, for example, stretch long tails behind them that make the passage of the encounter almost readable at a glance. Their bodies still suggest two separate spiral galaxies, but the tails reveal how much of their outer structure has already been claimed by the interaction. One does not need to know the equations of tidal dynamics to feel that the pair has crossed into a different condition. Their shapes no longer belong entirely to themselves. In a different way, the tadpole galaxy presents a similarly unsettling lesson. It retains a bright head-like core, but one immense trailing tail extends behind it, populated with star-forming regions and clumps of matter that testify to a violent gravitational past. The old image of the galaxy as a settled island of light becomes impossible to maintain. It now looks like something in transit between identities. Yet the long unraveling of shape is not limited to spectacular tales. Sometimes the deeper change appears in subtler distortions. Spiral arms bend out of their ordinary sweep. One side of a galaxy grows longer or brighter than the other. The disk may seem twisted, warped, or thickened. Dust lanes may no longer trace the calm geometry of a stable spiral. A ring may form or a plume may rise, or the center may appear doubled, as though the galaxy were carrying two conflicting versions of itself at once. Each of these signs points toward the same truth. The form we call a galaxy is not a fixed shell. It is the outward appearance of innumerable moving parts, and when their motions are disturbed, shape itself begins to hesitate. This hesitation is especially striking because galaxies are so often imagined as emblems of permanence. In photographs, spirals seem almost archetypal. Their curves feel mathematical, timeless, inevitable. It is easy to forget that the spiral pattern is not a sculpture, but a condition. It exists only so long as stars' gas and gravitational structure continue participating in a certain broad arrangement. Once an encounter disturbs that arrangement, the spiral does not shatter like glass. It unravels like a pattern, losing the circumstances that sustained it. This is why interacting galaxies feel sad in a very particular way. They are not merely being damaged, they are being deprived of the conditions under which their familiar beauty could continue. The outer regions are often the first to speak most clearly because they are the least tightly bound. There, at the edges of the disk, gravity from the companion galaxy can more readily pull stars and gas onto new trajectories. The central bulge may still look robust. The inner disk may retain enough coherence to reassure the eye, but the outskirts have already begun telling the truth. Their streams and tails announce that the galaxy's boundary is no longer secure. Material that once moved in loyal relation to the center is now answering to a larger field of forces. In a sense, the galaxy's edges become prophetic. They show what the rest of the structure has not yet fully admitted. This is one reason astronomers learn to value peculiar forms so highly. A tidal tail is not only beautiful, it is informative. Its length, curvature, brightness, and orientation can reveal something about the encounter that produced it. The geometry of the past, the masses involved the timing since closest approach, the degree to which the galaxies were aligned or tilted relative to one another, all can leave traces in the resulting shape. The disturbed galaxy becomes a kind of manuscript. Not an easy one to read, and never a perfect record, but a real one. The visible distortions are the handwriting of gravity across time. There is a profound difference between saying that galaxies interact and actually seeing what interaction does to form. Once tails, bridges, and warped disks enter the imagination, the old image of isolated galaxies becomes harder to trust. Even the calm systems begin to seem provisional. One starts to sense that every spiral is beautiful under conditions, every smooth elliptical a settled answer to older unrest, every visible order vulnerable to the arrival of another massive history. The collision no longer appears as an exceptional intrusion into an otherwise static universe. It starts to feel like one of the ways the universe reveals that no large structure is as self-contained as it first appears. At this stage, too, the timescale begins to make itself felt in a different way. A tail can extend across tens or even hundreds of thousands of light years, preserving in one visible arc the consequence of motions unfolding over hundreds of millions of years. To look at such a feature is to confront a strange compression of time into form. Human beings cannot sit and watch the tail lengthen. No eye follows it from birth to maturity. Yet there it is, suspended in the image, as if the galaxy had laid down a slow memory for us to inspect after the fact. These distorted systems become the astronomy of aftermath. They show not the instant of transformation, but the visible endurance of transformation once it has begun. Some of the most powerful merger stage atlases depend on precisely this insight. They gather galaxies at different visible moments of disturbance and allow the observer to move almost meditatively through a sequence of forms. Here, a pair remains mostly distinct but visibly perturbed. There another pair has produced stronger tails and deeper asymmetry. Elsewhere, disks overlap, nuclei approach, and the old structures are harder to separate. And farther along, still a remnant galaxy retains loops and streams like fading signatures of what once occurred. The beauty of such a sequence lies in the way it teaches the eye to see change not as accident, but as progression. The galaxies do not simply look strange, they are caught at different depths of unmaking. Still, it would be a mistake to think only in terms of outward pulling. The long unraveling of shape is a two-sided story. Matter is drawn out, yes, but matter is also redistributed inward. The same encounter that stretches tails into space can disturb gas and alter the deeper internal life of the galaxies. Shape, in other words, is not merely being lost at the edges, it is being reworked throughout the whole system. The visible tails and bridges are the most immediate poetry of the process, but they are not the only consequence. Beneath those elegant distortions, conditions are changing in denser and more hidden regions as well. That hidden change is part of what makes the outer beauty so deceptive. A tidal tail can look serene in a still image. It can seem almost ornamental, a ribbon of light cast off into the dark. Yet the same gravitational encounter that produced it may also be compressing gas, crowding clouds, altering the conditions for future star formation, and setting the stage for much more energetic transformations later on. The galaxy is not only losing shape, It is entering a new internal state. The outer features announce the disturbance, but they do not exhaust its meaning. Even the material, pulled into tails and streams, does not simply become irrelevant waste. Some of it may remain loosely bound and eventually fall back. Some may host knots of new stars. In especially rich tidal debris, small self-gravitating structures can emerge, making the boundary between destruction and creation even harder to draw cleanly. The encounter scatters matter, but scattering in the universe is not always equivalent to ending. Sometimes it is merely the beginning of a different arrangement. This is one reason the long unraveling of shape feels so rich as a subject. It resists every simple emotional category. It is mournful because an old form is being lost. It is beautiful because the loss becomes visible in extraordinary ways. And it is quietly generative because the redistributed matter has not finished participating in the story. The galaxies themselves, meanwhile, continue their slow movement through the aftermath of the first pass. Their paths have been altered. Their outer structures have become expressive of forces they cannot escape. If they separate for a time, they do so carrying visible marks of one another. They are no longer isolated worlds. They have entered a shared history that is now written into their very appearance. This is why the long unraveling of shape is not merely an intermediate phase between beginning and end. It is one of the most revealing phases of all. Here, the viewer can still recognize what the galaxies were, and can also see stretched across the dark the evidence that they will not remain that way. For a sleep documentary, there is something especially fitting in lingering here. The universe is often imagined through moments of climax, but this stage asks for another kind of attention. It asks us to notice the slow persuasion of gravity, the way form yields by degrees, the way a familiar shape becomes uncertain, not through instant violence, but through prolonged rearrangement. It reminds us that some of the deepest changes in nature do not announce themselves as explosions. They emerge as distortions, as asymmetries, as beautiful evidence that an old balance can no longer hold. And once the eye has learned to read those distortions, another question rises almost naturally. If the outskirts are being drawn out into tails and bridges, what is happening to the material that is not escaping outward? What becomes of the gas compressed, crowded, and redirected inside the disturbed galaxy? Because even as the outer form unravels into those long, luminous gestures, something else is beginning to gather, deepen, and ignite within the wreckage itself. For a while, the story of a galaxy collision can seem to belong entirely to loss. The first pass disturbs the old balance. Tails are drawn out. Bridges form. Familiar structure begins to loosen. A spiral that once appeared composed and self-contained now trails pieces of itself into the dark. If one looked only at those visible distortions, one might think the meaning of the encounter lies in unraveling alone. Gravity arrives, symmetry fails, and the galaxy enters a long decline from order into aftermath. But this is not the whole truth. The same event that tears a galaxy outward can also make parts of it burn more brightly than before. This is one of the strangest things galaxy mergers teach us. The forces that disorder a system do not simply erase. They gather, compress, redirect, and concentrate. Gas clouds that once drifted under calmer conditions are thrown into denser contact. Streams of material crowd into new regions. Shock fronts move through cold reservoirs of gas. Pressure rises. Instability deepens. In those changed conditions, the quiet raw material of future stars begins to answer differently to gravity. What looked from a distance like destruction starts to reveal another face. The wreckage becomes fertile. This is why the most famous interacting galaxies so often contain regions of startling youth. Against the older gold of long-lived stars, one finds knots and clusters of intense blue light signs of hot, massive, newly formed stars that were not there before the encounter began reshaping the system. In an ordinary spiral galaxy, star formation may continue in a more measured, distributed way, following the broad internal structure that the galaxy has carried for ages. In a merger, that pattern can change dramatically. Star birth may become concentrated, accelerated, even extravagant. A galaxy losing its old form may at the same time experience one of the most vigorous episodes of stellar creation in its history. At first, that seems almost contradictory. We are accustomed to treating ruin and birth as opposite conditions. A thing breaks apart or it begins anew. A structure decays or something fresh appears in its place. Yet in colliding galaxies, those processes can occur together, not as separate acts, but as different consequences of the same gravitational disturbance. Matter pulled outward into tails is one expression of the encounter. Gas compressed into star-forming knots is another. The collision does not pause its destructive work in order to create. It creates by disturbing the old arrangement so profoundly that new conditions become possible. No system shows this more vividly than the antennae galaxies. Seen through earlier telescopes, the antennae were only a faint and curious patch, a remote object among many such nebulae, whose full nature remained hidden by distance and instrumental limits. But with sharper modern observation, especially through Hubble, the pair became one of the clearest laboratories for understanding how a gas-rich merger can transform itself into a field of new light. Their long, arcing tidal tails stretch far into space, preserving the visible memory of the interaction. Their central regions appear tangled, crowded, and deeply disturbed. And within that confusion lie extraordinary numbers of young star clusters, bright blue condensations of recent formation, so numerous and luminous that they change the way astronomers thought about what galaxy collisions could produce. The effect is almost paradoxical when one first sees it clearly. Here are two galaxies whose old forms are plainly under strain, whose structures have been pulled and warped, whose encounter has scattered matter across immense distances. And yet within this disturbed environment, stars are being born in abundance. The brightness is not a denial of damage. It is damage translated into another process. The compression of gas, the collision of clouds, the altered pressure and flow inside the interacting system, all of these become the conditions under which stellar birth accelerates. The galaxy is no longer calm, but it is productive in a new and more turbulent way. This is one reason the antennae matter so much in the history of astronomical understanding. They are not merely beautiful, they are persuasive. They show with unusual richness that a merger is not only about shape being lost, it is also about light being reorganized. Hubble's observations revealed not just a handful of new clusters, but a vast population of them, more than 1,000, exceptionally bright young clusters scattered through the interacting pair. That abundance was important because it made the idea difficult to resist. A collision could trigger not merely local star formation, but a broad and dramatic episode of clustered stellar birth. The wreckage of one galactic order had become the nursery of another. Yet even here, where the image is so compelling, it is worth moving slowly. A starburst does not mean the whole galaxy has become one continuous furnace, nor does it mean every merger behaves this way. Galaxy collisions are varied events, and much depends on what the galaxies contain before they meet. This is where one of the most useful distinctions enters the story, even if it is rarely the part remembered in popular imagination. Some mergers are rich in cold gas. Others are relatively poor in it. Some encounters bring together systems still capable of feeding large new episodes of star formation. Others combine galaxies whose gas has already been depleted or heated, leaving them less able to respond with such brilliance. The difference matters because it reminds us that the same broad process of interaction can produce very different visible outcomes. Astronomers sometimes speak in this context of wet and dry mergers. The terms sound almost casual, but the distinction reaches deeply into the fate of the galaxies involved. A wet merger is one in which abundant gas remains available to be compressed, shocked, and driven into denser, star-forming conditions. Such an encounter is often visually dramatic. Blue clusters flare, dust lanes thicken and tangle. Infrared luminosity can rise as young stars heat surrounding dust. The system may look alive with disturbance, not only because its structure is unraveling, but because its internal reservoirs are being forced into new activity. A dry merger, by contrast, is typically a meeting between more gas-poor systems, often galaxies already dominated by older stellar populations. There, the merger can still reshape orbits, alter form, build mass, and change identity, but without the same flowering of new stars. The galaxy changes, but more quietly. The collision rewrites the structure without setting off the same visible blaze. This distinction protects the documentary from a simple but misleading idea, namely that every galaxy merger is a kind of cosmic fireworks display. Some are not. The antennae are unforgettable precisely because they are so rich in material that can answer disturbance with new light. But not every pair of interacting galaxies contains that same abundance of cold gas, and not every merger turns its damage into a spectacular burst of stellar youth. The deeper truth is not that collisions always ignite starbursts. It is that collisions can, under the right conditions, convert gravitational upheaval into extraordinary episodes of creation. And where that happens, the consequences reach beyond mere brightness. Starbursts alter the internal life of the galaxy. Massive young stars live quickly and die violently. Their radiation winds and eventual explosions begin feeding energy back into the surrounding medium. The very stars born from compression may in time help disrupt or heat the gas around them. The merger therefore becomes a layered process. Gas is compressed. Stars form. Those stars then begin changing the environment that produced them. The galaxy enters a state of accelerated history where consequences breed consequences and the calm rhythms of isolated evolution give way to something more intense. This is part of what makes the phrase "fire in the wreckage" feel appropriate. The fire is not metaphor alone. It is the actual ignition of stellar birth across disturbed terrain. But the wreckage matters just as much. These clusters do not appear in spite of the collision. They appear because of it. Their light is inseparable from the damage. To gaze upon them is to see one phase of disorder translated into another kind of order, one that may be short-lived in some places and enduring in others, but which unmistakably belongs to the merger's history. The star clusters themselves are especially moving because they compress vast scales into something the eye can almost understand. A galaxy is too large for intuition. A tidal interaction across tens of thousands of light years exceeds ordinary feeling. But a cluster, though still immense by human standards, feels more graspable. It is a place where the abstraction becomes local. Here, in a knot of blue light, one can sense that a new concentration of stars has emerged because the larger galaxy has been pulled out of its old balance. The collision ceases to be merely a matter of grand structure. It becomes a matter of neighborhoods of birth inside a disturbed world. And these neighborhoods need not remain confined to the main bodies of the galaxies. One of the great surprises of later observations has been how widely star formation can spread through interacting systems. In the debris of collisions in tidal features in gas stretched between galaxies, young clusters can appear in places that would have seemed unlikely under calmer circumstances. A merger does not simply light up the center. It can seed activity across an extended geography of disruption. The encounter becomes not just a central event, but a distributed one, reshaping where in a galactic system light is allowed to gather. This has important emotional consequences for the film's larger arc. Up to this point, the galaxy has been losing shape. Its old identity has been weakened. Its arms have loosened into tails and plumes. The viewer has been asked to dwell with a kind of cosmic sadness, the sadness of seeing something graceful cease to be securely itself. But here, the emotional texture changes. Not because the sadness disappears, but because it becomes more complex. The collision is no longer only an unmaking. It is also a release of potential that isolation may have kept dormant or more slowly expressed. The galaxy is still being transformed against its former nature, yet from that transformation comes an unforeseen brightness. In a sleep documentary, this is where awe can deepen into something quieter than spectacle. The point is not simply that the universe can produce beautiful fireworks. It is that beauty here is inseparable from disturbance. We are looking at a cosmos in which pressure, crowding, and broken equilibrium can become the precondition for new radiance. That is a more unsettling and more interesting kind of beauty than simple harmony. It suggests that the universe does not preserve life by preserving stillness. Sometimes it builds by forcing matter through crisis. Still, we should resist romanticizing this too quickly. A starburst is not a happy ending, concealed within the wreckage. It is a phase, often intense, often costly. Gas consumed rapidly in star formation may not remain available for later generations. Energetic feedback from young stars can blow material outward, stir turbulence, and change the thermal state of the system. The very brilliance that makes a merger so visually striking can also be part of a longer path toward exhaustion in certain regions. Once again, the universe refuses simple categories. The fire is creative, but it is not innocent. It draws from stored reservoirs and alters what remains. It is another chapter of transformation, not a return to the old calm. And yet there is no denying the grandeur of the process. To think that a galaxy, in the midst of losing its familiar form, can kindle such an outpouring of new light is to feel more sharply than before that a collision is not an interruption of cosmic history. It is cosmic history. The same gravitational encounter that tears tails through space also gathers clouds into stars. The same loss of symmetry that weakens the old galaxy gives rise to new concentrations of brightness that would never have emerged in quite the same way otherwise. The event is not a deviation from how the universe works. It is one of the most revealing ways the universe works. By now, the viewer may begin to sense that the merger is changing direction in a deeper sense. What was first visible in the outskirts, in tails and bridges and unraveling structure, is beginning to work inward as well. Gas does not only light up in scattered knots. Some of it is being driven toward the central regions of the galaxies, toward denser and more obscured interiors, where the consequences of compression may become even more dramatic. The outer wreckage glows with young stars, but the center is becoming more crowded, more active, and more difficult to see through. The collision, which first announced itself by drawing matter outward, is now preparing another movement, one that leads not into the open elegance of tidal tails, but into the hidden intensity of the galactic core. By the time a galaxy collision reaches this deeper phase, the story is no longer written only in what has been pulled outward. We have already watched spiral arms loosen tails, lengthen bridges form, and young clusters flare in the debris. From a distance, it can seem as though the encounter expresses itself mainly by unraveling the galaxy at the edges. But a merger does not only cast matter away from the center, it also does the opposite. It drives part of the galaxy inward. Simulations and modern reviews of galaxy mergers describe this as one of the process's central effects. Gravitational torques cause gas to lose angular momentum and fall toward the central regions where it can help feed starbursts and supermassive black holes. This is where a collision begins to change a galaxy, not just in outline, but in metabolism. Until now, the disturbance has been easy to picture in visual terms. A shape bends, a tail extends, a familiar symmetry fails. But the inward fall belongs to another kind of transformation, one that is often obscured by dust buried in crowded cores and expressed not only through visible light, but through heat turbulence and hidden accretion. A galaxy that once looked calm from the center, outward may now be feeding its own core in unusual ways, crowding gas into regions where pressure rises, radiation intensifies, and old internal balances can no longer hold. There is something fitting about this inward turn. The outer stages of a merger make the galaxy seem less self-contained. Matter streams away, structure spills into space. But as some material is flung outward, other material is losing its ability to remain in wide, orderly circulation. It is being drawn down into denser and more consequential neighborhoods. In that sense, a merger is doing two things at once. It is making the galaxy more diffuse at the edges and more concentrated at the center. The same event that stretches the system into tails and shells can also tighten it at its heart. This inward movement is not simply a matter of more gas arriving at the center. It changes what the center is able to become. In an undisturbed galaxy, gas may continue orbiting for long spans without feeding the nucleus efficiently. During a merger, that restraint weakens. Material that once kept much of its angular momentum can be torqued, shocked, and redirected. The central regions become more crowded and often more obscured. Dust thickens. Star formation may intensify in compact areas, and if a supermassive black hole waits there, as it does in the center of large galaxies, the merger can provide it with a richer and more chaotic supply of fuel than isolation would have offered. This does not mean every merger instantly produces a brilliant active galactic nucleus. The reality is more patient and more complicated. Astronomers have long suspected that mergers can trigger nuclear activity, but recent work tracing active galactic nuclei across the merger sequence shows that the strongest statistical excess can peak shortly after coalescence, rather than at the earliest visible stages. One large study found that the excess of active nuclei is highest in the first 0 to 0.16 billion years after coalescence, and that in the pre-merger phase, tidally triggered inflows may increase the covering fraction of nuclear dust, making the center both busier and harder to see. In other words, the inward fall often begins before the center becomes fully legible to us. The merger can hide the very thing it is helping to feed. That hiddenness is part of what gives this phase its mood. Earlier sections of the story were full of visible gestures. Tales were written across space. Bridges glowed in the open dark. Star clusters flashed blue in the disturbed outskirts. But the inward fall belongs to the more secretive life of the merger. It asks us to imagine pressure building behind curtains of dust. It asks us to picture not one dramatic moment, but many streams of gas losing freedom, many clouds colliding, many parcels of matter sinking toward a center that is becoming denser, hotter, and harder to read by ordinary light. The galaxy is no longer only expressing itself outward. It is gathering itself inward into a more intense kind of obscurity. Few objects make this clearer than NGC 624. Even in visible images, it looks troubled, a tangled remnant of two galaxies deep in the act of becoming one. But what gives the system its peculiar power is what lies near the middle. NASA's current description notes that two supermassive black holes sit within this jumble, spiraling closer together and separated by only about 3,000 light-years inside a galaxy spanning roughly 300,000 light-years. Their proximity makes the future plain. They are now too close to escape one another and will eventually form a single larger black hole. This is not simply a story of outer distortion anymore. It is the story of two galactic hearts, once far apart, in separate galaxies, being brought into the same tightening interior. To linger on NGC 6240e is to feel the full seriousness of the phrase inward fall. Two galaxies have already passed through the earlier stages of disturbance. Their forms have tangled. Their gas has been driven and compressed. Their old separateness has been undermined so deeply that even their central black holes now share one disordered environment. It is a reminder that galaxy collisions do not merely wound the outskirts while leaving the center untouched. Given enough time, the encounter reaches all the way in. The nucleus itself becomes part of the merger's unfinished work. Yet NGC 6240 also helps us see why this phase is not only about black holes in the dramatic isolated sense that popular imagination prefers. The black holes matter because they reveal what the merger has already accomplished in the surrounding galaxy. To bring two supermassive black holes to such closeness requires the long draining of orbital freedom across the whole system. Stars, gas, dark matter, and dynamical friction all participate in that history. The famous pair of nuclei at the center are not separate from the merger's broader transformation. They are among its deepest expressions. The galaxy's visible confusion, its dust, its crowding, and its inner violence all belong to the same long rearrangement. If NGC 6240 shows the inward fall as convergence, Stefan's quintet shows it as a more layered and revealing chemistry of the center. The group is visually famous for its crowded, interacting appearance, but Webb's observations of NGC 7319 within the quintet offered something especially valuable for this stage of the story. NASA reports that NGC 7319 harbors an active galactic nucleus powered by a supermassive black hole, about 24 million times the mass of the Sun, radiating energy equivalent to 40 billion suns. Webb's NIR-SPEC instrument pierced through the shroud of dust to measure bright emission from outflows of hot gas near the black hole in wavelengths not detected there before. That language matters. Pierced through the shroud of dust. It tells us that the center of a merging or strongly interacting system is often not merely active, but veiled. The interesting physics is there, but it must be reached through obscuration. In NGC 7319, Webb mapped different phases of gas around the active nucleus. Atomic hydrogen traced the structure of the outflow. Iron ions marked where hot gas was located. Molecular hydrogen traced both outflowing gas and the cold, dense reservoir that serves as fuel for the black hole. So, even here, near one of the most energetic points in the system, the merger presents a dual movement. Material is being expelled in outflows, yet fuel remains present as part of the same central ecology. The nucleus is not simply swallowing. It is breathing in a more violent way. This is one of the most important corrections the inward fall can offer. It would be easy to picture the process as a one-way sink, as though the merger merely funneled gas toward the center until the black hole fed, and that was the end of it. But real galactic centers are more dynamic. Inflows help sustain dense central activity. That activity can then drive feedback heating winds and outflows that reshape the surrounding gas. The center becomes a site of exchange rather than simple consumption. Matter loses angular momentum and falls inward. But once the nucleus grows active enough, some of that accumulated energy begins pushing back outward into the galaxy. The merger, in other words, can create a center that no longer passively sits at the middle of the system. It becomes an engine. There is a deep emotional shift in realizing this. Earlier, the galaxy's transformation felt visible and almost sculptural. One could trace it in arcs and tails. Here, the transformation becomes harder to picture with the same serenity. The center is crowded dust enshrouded hot and active. The galaxy no longer seems merely wounded or merely fertile. It seems metabolically altered. It is processing matter at a different rate, in a different geometry, under different internal pressures. The merger has become not just a change in form, but a change in appetite and response. And yet even this more violent interior remains part of the same slow-motion story. Nothing here happens in an instant from the galaxy's point of view. Gas is driven inward over time. Dust thickens, nuclei approach, obscuration rises, activity strengthens. In some systems, the central black hole becomes conspicuous. In others, it remains partly hidden. In still others, the full excess of nuclear activity may become most evident after the galaxies have already coalesced. The merger does not obey a single script, but the pattern is clear enough. The inward fall is one of the ways the collision reaches beyond appearances and alters the deep future of the galaxy. By this stage, the old spiral identity is not merely stretched. It is being crowded out from within. Whatever order once governed the galaxy's center in quieter times has been replaced by something denser and less stable. Tails may still glow outside. Young clusters may still burn in the wreckage. But the core is no longer the calm anchor it once seemed. It has become part of the disturbance, perhaps even its most consequential part. And once that happens, the final question can no longer be postponed. After the inflow, after the starburst, after the buried feeding, and the tightening nuclei, what kind of galaxy is left when the spiral can no longer return to itself? What remains when the pair is no longer a pair, but a single altered remnant, carrying the memory of everything it has passed through? At some point in every long transformation, there comes a stage when the old name begins to feel less certain than before. Not wrong exactly, not yet entirely unusable, but strained. A spiral galaxy can endure a great deal before it fully stops being recognizable. It can survive the first pass. It can carry tidal tails, warped arms, bridges, shells of debris, and still retain enough of its former character that the eye continues to call it by its old identity. Even through the turmoil of compressed gas and inward falling matter, one can still trace the memory of what it was. But there comes a later phase, quieter in some ways than the earlier spectacle, when the question shifts. The question is no longer how badly the galaxy has been disturbed. The question is what it has become. This is the stage after the spiral. That phrase does not mean the galaxy has ceased to exist, nor does it mean that everything the spiral once contained has been erased. Stars remain. Gas remains, though altered. Dust remains. Tidal features may still sweep outward into the dark, preserving visible evidence of the encounter. Young clusters may continue to glow. In some systems, the center is still active, still crowded, still full of the consequences of inward fall. But the old spiral order, the coherent, broad pattern that once gave the galaxy its familiar identity, can no longer reassemble itself in the form it once had. The galaxy has crossed a threshold. It is no longer best understood as a disturbed version of its former self. It is a remnant, and the word matters because it tells us that what survives is not simply what existed before. It is what remains after transformation has done its work. There is something almost philosophical about this stage because it forces us to think carefully about continuity. If the stars are still there, is it the same galaxy? If the matter is largely preserved, but the arrangement is altered beyond recognition, what exactly has ended? Human language struggles here because we are so used to tying identity to substance. A thing remains itself because it still consists of the same material. But galaxies teach another lesson. Their identity lies not only in what they contain, but in how that content is organized through motion, symmetry, and time. When a spiral loses the conditions that sustained its arms, its disk, its broad patterns of circulation, it loses more than shape. It loses a way of being a galaxy. That is why late-stage merger remnants are so important to the larger story. They show that a collision is not merely an event in which galaxies suffer damage and then persist as somewhat altered versions of themselves. Under the right circumstances, the merger changes the category itself. The old pair becomes one system. The structure becomes more spheroidal, more tangled, or more diffuse in its visible memory of previous order. The tails may remain for a while like fading signatures of a dramatic past. But the main body settles into something different, and the eye understands even before the equations do that a threshold has been crossed. NGC 2623 is one of the most haunting examples of this condition. It is often described as a late-stage merger, and that phrase is exact in the most useful way. When we look at it, we are not looking at two galaxies beginning to notice one another, nor even at two clearly distinct systems deep in the process of passing through collision. We are looking at a single disturbed remnant that carries long tidal tails streaming out from its core, the surviving evidence of the galaxies it once was. Those tails stretch away like afterthoughts, written in light, long, elegant, and unmistakably tied to an earlier structure that no longer exists in the same form. The center, meanwhile, has become one. The pair is no longer a pair in any meaningful visual sense. The merger has crossed beyond encounter into consequence. This is what makes NGC 2623 so emotionally effective in the story of galactic transformation. It is not as immediately legible as a system with two clearly visible interacting spirals. There is less of the dramatic tension of the near approach, less of the startling visual conversation between recognizable separate forms. Instead, there is a more difficult beauty. One has to read it as aftermath. The galaxy no longer displays the process in its opening or middle chapters. It displays what happens once the old distinction has collapsed and a new body has begun to settle out of the wreckage. And yet the wreckage has not stopped speaking. The tails remain. New stars are still visible in the system, and bright clusters linger in the debris. Some of the material pulled out during the interaction may still be loosely bound enough to fall back inward over time. So, even at this stage, after the central union, the galaxy is not static. It is still metabolizing its own past. This is one of the deepest truths of merger remnants. They are not quiet simply because the most obvious part of the collision is over. The event continues within them, in the slow settling of orbits, in the dispersal or return of tidal material, in the aging of star clusters, in the fading of youthful brilliance, in the long reorganization of everything that remains. If NGC 2623 shows the remnant as a wounded but unified survivor, NGC 7252 shows something even more consequential. It is often called the Atoms for Peace Galaxy, a name borrowed from the resemblance of its loops and trails to a stylized atomic symbol. The nickname is memorable, but what matters more is the system itself. Here we see a merger remnant believed to be around 1 billion years beyond the main collision phase, a galaxy that has moved far enough from the original encounter that the process can be felt as history rather than immediate violence. The body of the remnant is smooth and elliptical in appearance compared with the spirals that likely gave rise to it. The tails and loops remain, but they now feel less like active tearing and more like the fading script of something already completed. NGC 7252 matters because it helps strengthen a powerful idea in modern astronomy that major mergers between spiral galaxies can help produce giant elliptical galaxies. This was not merely an abstract speculation. Observations of the remnant, including the populations of young massive star clusters within it, gave astronomers reason to think that what they were seeing was not just a temporary accident of damage, but a plausible route by which one familiar galactic form could become another. The significance of that shift is easy to miss unless one pauses over it. For much of human experience, galaxies seem like finished categories: spiral, elliptical, irregular. Distinct types, as though nature had arranged them separately from the start. Merger remnants, like NGC 7252, suggest something more fluid and more historical. A galaxy may not simply be born into one form and remain there forever. It may pass through transformation so severe that what comes after belongs to another family altogether. That possibility changes the meaning of everything that came before. The tidal tails were not just decorative consequences. The starbursts were not just temporary fireworks. The inward fall of gas and the convergence of nuclei were not isolated episodes. All of them belong to a larger passage from one galactic identity to another. The old spiral was not merely injured, it was being translated. Translation is a useful word here because it avoids some of the false clarity of terms like destruction and rebirth. A translation preserves something and changes something. It carries material across a threshold of form. It does not leave the original untouched, but neither does it reduce it to nothing. Merger remnants are like that. The stars of the old galaxies persist. Their gas, though consumed, heated, expelled, or rearranged, still participates in the new system. Their black holes may continue inward toward eventual union. Their tidal debris keeps the memory of earlier geometry alive for a while longer. Yet the overall structure has entered another language. The galaxy can no longer speak itself in spiral form. There is a special calm to this phase that suits the deeper mood of the documentary. Earlier stages were full of visible drama. Tails lengthened, gas ignited shapes, warped centers darkened with activity. Here the transformation has become more settled, but no less profound. The remnant often appears smoother, more composed, less openly violent. And that deceptive calm is part of its power. It reminds us that the outcome of great disturbance is not always continued spectacle. Sometimes it is a new stability, one that contains the past without visibly performing it at every moment. An elliptical remnant may look serene, but its serenity can be the late fruit of colossal upheaval. This is also where the theme of memory becomes especially important. Galaxies do not remember in the human sense, but remnants preserve the traces of what has happened to them. Loops, shells, tails, streams, unusual cluster populations, kinematic oddities. All of these can remain as signatures of merger history. A smooth remnant body does not mean a blank past. It means the past has been absorbed into a different visible order. Astronomers read that order, carefully searching for the lingering evidence of what once passed through it. In that sense, a remnant is not only a result, it is an archive. And what an archive it is! In one system, there may be young globular clusters that would not have existed without the merger. In another, shells or faint tails may reveal how the final body was assembled. In another, the central kinematics may show that the stars no longer orbit in the same organized pattern characteristic of a spiral disk. The remnant holds all these stories at once, though never in a simple or fully transparent way. The galaxy has changed form, but the evidence of change survives in scattered layers. To study a remnant is therefore to study not just the end of a collision, but the persistence of history inside a new arrangement. This persistence is important because it keeps the story from becoming too neat. It would be satisfying, perhaps, to imagine that once a merger remnant forms, the earlier galaxies are simply gone, and the new one is fully itself. But the universe rarely grants such perfect closure. Tidal material may continue falling back. Star formation may continue in pockets. Black holes may still be approaching one another over long time scales. The remnant may look settled from a great distance, while still carrying immense unfinished processes within. So, when we speak of what remains after the spiral, we are not speaking of a cleanly completed object. We are speaking of a galaxy in which the past has been reorganized into a new, but not entirely final condition. This is where the chosen angle of the documentary fully comes into focus. We began not with spectacle, but with a question of identity. What really happens when galaxies collide, if the event is not simply a smash, but a slow transformation? The answer by now is becoming plain. Gravity does not merely damage a galaxy. It can strip it of the conditions under which it once made sense as itself. The spiral loses its old coherence. The pair loses its separateness. Matter is cast out, driven inward, reignited, obscured, and reassembled. And what emerges can be a galaxy whose substance remembers the old worlds, even while its form belongs to another future. There is a quiet grandeur in that. We often think of the universe as a place of categories, as though its beauty lay in the stability of its forms. But merger remnants suggest another beauty, one rooted in passage. A galaxy need not remain what it has been in order to continue existing. Its continuation may require the loss of its former identity. Its future may depend on surrendering the very shape that once made it recognizable. In that sense, a remnant is not simply evidence of survival. It is evidence that survival in the cosmos may mean becoming unrecognizable to one's own past. And once that thought has settled, the documentary is ready to widen its gaze. Because if one spiral can become something else through collision, then such encounters are not merely dramatic episodes scattered here and there through an otherwise orderly universe. They are part of the universe's way of building. The remnant is not just the end of one story. It is a clue to a much larger one in which galaxies grow, combine, and remake themselves across cosmic time, and in which even our own Milky Way must be imagined, however uncertainly, within that same long logic of unmaking and creation. By the time we arrive here, the collision no longer feels like an isolated spectacle. It no longer belongs only to one pair of galaxies caught in a beautiful disaster, or to one remnant carrying faint loops of memory through the dark. The deeper truth has been gathering quietly beneath every stage of the story. What happened to those galaxies was not merely misfortune. It was not an interruption in the universe's order. It was one expression of that order. This is the thought that changes everything. A galaxy merger is not simply a dramatic event that happens now and then against the calm background of cosmic history. It is part of how cosmic history proceeds. The universe does not build only by preserving what already exists. It also builds by bringing structures into relation, by letting them disturb one another, by loosening older forms so that larger and different ones can emerge. If the earlier sections of this documentary have asked us to watch a galaxy lose its shape, this final section asks us to see that loss in a wider frame. The unmaking was never only an ending, it was also a method. That does not mean every galaxy in the universe owes its existence mainly to violent mergers. The cosmos is subtler than that. Galaxies also grow by drawing in gas from their surroundings, by forming stars over long spans in relative quiet, by evolving through internal processes that need no major collision to set them in motion. Some galaxies lead calmer lives than others. Some are shaped more by environment, by slow accretion, by gentle encounters, or small companions, rather than by catastrophic union with an equal. But once one steps back from individual cases and looks across cosmic time mergers, remain one of the great instruments by which galaxies gather mass change category, alter structure, and become what they were not before. There is a certain humility in admitting that the sky is historical in this way. When we first look at galaxies, especially in their most elegant forms, they can seem timeless. A spiral appears so complete that one is tempted to think of it as finished. An elliptical seems so settled that it almost resembles a final answer. But nothing in the universe is final in that sense. Galaxies carry pasts within them. Their shapes are not static facts. They are temporary arrangements reached through long sequences of accumulation, disturbance, collapse, ignition, and recovery. To see the universe clearly is to stop asking only what a galaxy is and begin asking what has happened to it. Once that question is asked, the sky changes character. Every smooth elliptical becomes in some quiet way suspicious. Was it always this calm, or is its calm the late result of upheaval, too old to perform itself openly? Every massive galaxy begins to feel less like a solitary monument and more like a layered consequence. Even the most graceful spiral can no longer be regarded as untouched innocence. Its order may be genuine, but it is not immune. It exists under conditions. It exists within a universe where proximity to other great systems can one day redraw everything. If we carry that thought backward toward earlier cosmic ages, the meaning grows even larger. The early universe was denser, younger, and more crowded with forming structures. Galaxies were smaller, clumpier, more irregular, more often engaged in encounters, whose consequences had not yet settled into the categories we now recognize so easily. What looks from our present distance like a mature and legible universe was once much more fluid. Many of the grand systems we admire today were assembled over time through repeated episodes of growth, combination, and rearrangement. Some collisions were major and dramatic, two comparably large galaxies reshaping one another beyond recognition. Others were smaller, quieter, the steady swallowing of lesser companions by larger hosts. But the principle remained. Cosmic architecture was being built through contact, influence, and incorporation. This is why the merger remnant matters so much. It is not just the answer to one local story. It is a clue to a universal tendency. A galaxy can become larger not only by making stars from its own gas, but by inheriting stars from another. It can become smoother not only by aging quietly, but by scrambling the ordered orbits that once gave a disk its distinctive form. It can change its stellar population, its central density, its angular momentum, even its long-term fate, because another galaxy came near enough to enter the same history. In the universe, inheritance is not always gentle. Sometimes it comes through collision. And yet, even here, we should move carefully, because the cosmos rarely grants one mechanism total power. It would be easy to tell a simpler story and say that mergers made all grand galaxies, that every elliptical is merely the fossil of a spiral collision, that every period of intense star formation is merger-driven, that the history of the universe is one long chain of violent pairings. But that would betray the same impatience we have tried to resist from the beginning. The truth is more interesting because it is less absolute. Mergers are crucial, but not exclusive. They are one of the universe's great tools, but not its only one. In some eras and environments, they matter more. In others, gas supply, internal dynamics, or quiet accretion may govern the pace of change more strongly. The universe builds by many routes. What collisions reveal is not the whole map, but one of its deepest patterns. Perhaps that is why they feel so profound. A galaxy merger is dramatic enough to be visible, but subtle enough to remain honest. It does not tempt us into the fantasy that nature works through simple destruction, nor does it allow us the comfort of pure stability. Instead, it shows a world in which order changes form. Matter is neither preserved unchanged, nor thrown meaninglessly into ruin. It is rearranged. The same stars can belong first to one system and later to another. The same gas can spend ages in a disk, then be thrown into tails, compressed into clusters, driven toward a core, and eventually dispersed or exhausted. The universe is not only making things, it is continuously redistributing belonging. That phrase may be the quiet center of this whole documentary. Galaxies do not merely contain matter. They give matter a kind of temporary citizenship. A star belongs to a spiral arm for a while. Gas belongs to a disk, to a lane, to a pattern of rotation. A central black hole belongs to one galactic history until collision slowly brings another one close enough that the two destinies tighten into one. Then the old belonging begins to fail. The matter is still there, but it is answering to a new arrangement. That is what a merger truly accomplishes. It changes the map of allegiance inside the cosmos. In that wider sense, the universe builds not only by adding, but by reassigning. Smaller galaxies are absorbed into larger ones. Stellar streams are left behind as lingering evidence that incorporation is never perfectly clean. Outer halos preserve whispers of past accretions. Massive galaxies in crowded regions may grow by repeatedly folding lesser companions into themselves, so that what seems like a single calm giant is actually a layered archive of many smaller lives. Even without the dramatic beauty of a grand major merger, the same logic persists. Growth through unmaking, continuity through absorption. New structures formed from old structures, losing the right to remain separate. And then inevitably we turn homeward. The Milky Way has always felt different in the human imagination, because it is not merely a galaxy to us. It is the night sky's pale river, the larger body to which our own sun belongs, the quiet luminous band above deserts, mountains, ships, fields, and sleeping cities. To speak of galaxy collisions in general can feel grand and distant. To imagine our own galaxy subject to the same slow laws is to feel the thought arrive more intimately. It reminds us that the processes we have been watching elsewhere are not foreign to our cosmic address. They are part of the same universe that made our sky. In one sense, this is already true. The Milky Way did not appear fully formed in serene isolation. Like other large galaxies, it carries the marks of a layered past. It has grown over time. It has gathered smaller companions, absorbed them, drawn some into stellar streams, and built part of its halo through long histories of accretion and incorporation. Even without invoking some distant future event, our own galaxy already belongs to the same general story. It, too, is a structure assembled through time, preserving within itself the evidence that galaxies are historical beings. But the future gives that truth a more haunting form. For many years, popular astronomy told a relatively simple story. Andromeda, our nearest large galactic neighbor, was approaching the Milky Way, and the two were destined billions of years from now to collide and merge. The image was irresistible. Two spiral galaxies, each immense, drawn slowly together across the dark, eventually tearing at one another, passing through kindling bursts of star formation, and settling into some larger remnant long after the Earth, and perhaps even the Sun, had passed into histories of their own. It was the perfect cosmic ending because it made our own galaxy part of the same majestic logic we observed elsewhere. But like so much else in astronomy, the story has grown more careful as the measurements have improved. The broad fact of Andromeda's approach remains, yet the exact future is less neatly certain than older tellings suggested. Updated work using Hubble and other measurements has complicated the prediction. A collision remains possible, even plausible, on very long timescales, but not inevitable in the simple cinematic sense the popular imagination once preferred. The Milky Way and Andromeda may indeed merge within the next 10 billion years. They may also avoid a direct collision on the first great passage. Their future depends on details of motion mass, and the wider local group environment details subtle enough that the honest story now includes real uncertainty. This uncertainty is not a weakness. It is in fact a fitting ending for a documentary like this one. From the beginning, we have tried to replace spectacle with something truer. Galaxy collisions are slower than the word suggests, less literal than popular language implies, more transformative than first intuition allows. Why should the future of our own galaxy be any different? The point is not to promise a neat apocalypse. The point is to understand that the Milky Way exists within the same long grammar of influence, proximity, and change as every other large galaxy. Whether the future holds a full merger with Andromeda or a more complicated dance, our galaxy is not exempt from cosmic history. It is one of its participants. And perhaps that is at the final widening of meaning. We often speak as though the universe were made of things, stable nouns laid out across the dark. But a galaxy collision reminds us that the universe is also made of verbs. Drifting, pulling, falling, compressing, igniting, fading, returning, merging. Galaxies are not merely objects. They are episodes in motion, arrangements temporarily held together by gravity and then slowly altered by new circumstances. To understand them is to understand that existence, at the largest scales, is not static presence, but ongoing transformation. So when we say that the universe builds by unmaking, we do not mean that it delights in ruin. We mean that form is never the end of the story. The spiral is beautiful, but its beauty is conditional. The elliptical is serene, but its serenity may be inherited from violence. The remnant is not lesser, because it has lost what came before. It is the next expression of matter under time. In the cosmos, continuity often requires surrender. A galaxy does not remain part of the universe by preserving its old shape forever. It remains part of the universe by entering when the moment comes into another arrangement. That may be the quietest and most difficult truth these collisions offer us. We began with the expectation of impact and found instead a lesson in transformation. We looked for smashing and found gradual redistribution. We imagined endings and found passages. The universe, it seems, is not only a place where things exist, it is a place where things cease, combine, and become again. And under that understanding, The night sky changes one last time. The galaxies we see are no longer remote ornaments pinned to eternity. They are histories still unfolding forms, still vulnerable to time structures, beautiful precisely because they are not permanent. To watch them collide, even in imagination, is to watch the cosmos continue its patient work of rearrangement. Not hurried, not cruel, simply faithful to its own immense logic, in which even the loss of one form can become the beginning of another, and in which creation so often arrives wearing the face of change. By now, the old picture of a galaxy collision may feel very far away. Not because the reality proved gentler, but because it proved stranger. What looked at first like a cosmic crash revealed itself as a long surrender of form. Spiral arms loosened. Tidal tails drifted outward like remnants of a forgotten gesture. Gas fell inward, star clusters flared into being, and beneath it all, gravity kept working with quiet patience, never hurrying, never needing spectacle to accomplish something immense. The galaxies were not simply broken, they were translated into another state of being. There is something humbling in that. We often imagine creation and destruction as opposites, as if one must end before the other can begin. But the universe does not always separate them so neatly. In these vast encounters, disorder becomes a condition of renewal. The same forces that erase symmetry can kindle new light. The same event that strips away identity can also build a different future from the debris. And perhaps that is why galaxy mergers stay with us, not only because they are beautiful, and not only because they are immense, but because they reveal a truth that feels larger than astronomy itself. Stability is never the whole story of existence. Sometimes becoming requires the loss of what once seemed permanent, and somewhere far beyond the span of any human life, our own galaxy may one day face a future shaped by the same slow logic, though even that remains uncertain. Perhaps that is a fitting place to leave the question, not with a prediction and not with an ending, but with a gentler recognition. The universe is not built only by preserving what it has made. It is also built by letting forms change, by allowing old structures to loosen, and by drawing new worlds out of their rearrangement. In that sense, a galaxy collision is not merely an ending stretched across billions of years. It is one of the quiet ways the cosmos continues its work.